let's prove a fun little theorem for ourselves. Given triangle ABC is a right isosceles triangle, and D is the midpoint of AC, and we're told that AB, that side, is the one that's congruent to the other side, BC, then our mission is to prove that triangle BDC is isosceles. Now we have to draw a picture of this, and it's going to be really convenient to draw this in the coordinate plane. So this is a great opportunity for us to return to the coordinate plane. I know that the triangle is a right triangle, so let me remind you that that means that we have the luxury of actually having one of the corners be the origin, and the legs will actually reside along the x and the y axes. So we can only do this with right triangles, but it's a great luxury that I want to take advantage of. Okay, now, what do I know? So I've got A, B, C. It's a right triangle. So I'll indicate that like this. And I know that D is the midpoint of AC. So I'll just visually draw that in. And I'm going to call this D. And now what am I supposed to show? I'm supposed to show that the triangle BDC, so this triangle right here, is in fact isosceles, which looking at it visually seems to indicate to me that I need to show that that length is equal to that length. Well, I know there's a distance formula, and so I can actually use the distance formula to compute this length, the distance between these 2 points, and this length, and see if they're the same. If they're the same, I'm done. Well, I don't know the coordinates of any points, but now I'm allowed to actually pick them and just call them unknown letters. So here I go. There's a couple things we do know. We know my favorite point, B, that's the origin, so I know the coordinates there are 0, 0, so that's great. We also know that the y-coordinate of C is 0 because it lies on the x-axis. But I don't know the x value, so I'm going to let it be an unknown. Now, I could, say, call it like m. That would be fine. But notice that at some point, I'm going to want to find a midpoint, which means I'm going to take half of that. So let me start off by actually calling this 2 times an unknown. So when I take half of it, I'm going to be able to easily find that midpoint. So I'm going to call the coordinates of this point 2r, 0. And I'm going to use the same idea here, and I'm going to call this point 0 because there's no movement in the x direction, and I'm going to call this 2s. Now, I can use the midpoint formula to actually find the coordinates of D. What is it? Well, what do? I take the x values and add them up. So I take 2r plus 0, and then I divide by 2. So I just get r. So I see that the x-coordinate for D is going to be r. And the y-coordinate, I add these 2 values up. 2s plus 0 is just 2s. Divided by 2, I just get s. And so see, the coordinates of the midpoint are just rs. And notice how nice they are. There's no halves or fractions. Well, now I've got to compute distance, and now we can do that pretty easily. Let's find the distance between B and D, or the length of that line segment. Well, that equals the square root of, I take the differences in the x, so that's r minus 0 squared, and the differences in the y, that's s minus 0 squared. Well, those zeros really don't impact things too much, and so I'm just left with the square root of r squared plus s squared. It looks a little bit abstract, but that's okay. I'm not asked to find the value. I'm just supposed to compare that value to this length. So let's now compute the other length. So here we go, computing the other length. That's going to be the length of CD. That equals the square root, and we're going to use the same formula. So we look at the difference in the x's. So that's going to be 2r minus r. Well, 2r minus r is just r, and then I square that difference. Plus, and then I take 0, and I subtract off s. That gives me a negative s, but then I square it. And remember, negative s squared is just the same thing as s squared. And so I get that for that distance. And it still looks abstract, but notice something. These are the exact same quantities. Square root of r squared plus s squared, square root of r squared plus s squared. So I see for certain that this has the same length, BD has the same length as CD. And therefore, since these lengths are equal, these 2 line segments are congruent, And that means that this triangle is isosceles. So there you have it. You can see a wonderful example where using the coordinate plane allows us to prove this really cool theorem. Congratulations and have fun proving theorems for yourself. See you soon.